From thirst to satisfaction, from empty to full in rotation, each bottle tells a story of exchange, of logic, of glory. What starts as a simple sip turns into a cycle of gain, where empties hold value and nothing is ever in vain. Today we explore this elegant puzzle, the water bottles. In this problem, we are faced with a very practical scenario discussed as a puzzle. Imagine you are given a certain number of water bottles, all of them full. Each time you drink one, you are left with an empty bottle. But there's a rule. If you collect a certain number of empty bottles, you can exchange them for a brand new full bottle. The challenge is to figure out the maximum number of bottles you can drink in total before no further exchanges are possible. This problem combines a simple cycle of consumption and exchange, but teaches us an important lesson in simulation and greedy strategies. Let's take our first example. Suppose we start with 9 full bottles and the exchange rate is 3 empties for 1 new bottle. First, we drink all 9 bottles, leaving 9 empty bottles. These empties can be exchanged for 3 new full bottles, which we also can drink, giving us 3 more empties. Those 3 empties can be exchanged again for one last bottle. At the end, we drank 9 plus 3 plus 1, giving us 13 bottles in total. This example clearly shows how exchanges add extra value to the initial stock of bottles. Now let's consider a slightly larger example. We start with 15 full bottles and this time we need 4 empties for one new bottle. After drinking 15, we have 15 empties. With this, we can make 3 exchanges, giving us 3 more bottles. After drinking those 3, we are now have 3 new empties plus the leftover 3 from before, making 6 empties. From these 6, we can exchange 4 for one more full bottle. That brings our total to 19 bottles. Once no more exchanges are possible, the cycle ends. Notice how the total grows beyond the starting number due to the exchange mechanism. The problem also gives us boundaries or constraints. The number of initial bottles is always between 1 and 100. The exchange rate is at least 2 and at most 100. These small limits mean that simulation is perfectly valid approach. We do not need complex formulas or heavy computation. A simple loop repeating the drinking and exchanging process until it's no longer possible will always work efficiently. Before jumping into the code, let's highlight some key observations. Every full bottle gives us exactly one drink, but it also produces one empty bottle that still has value. This means nothing is wasted. The cycle continues as long as we have enough empties to perform an exchange. The problem becomes one of repeating this process until the empties can no longer be traded in. The greedy strategy works here. We should always exchange as soon as we can because delaying it has no advantage. So how do we solve it? We begin by counting the initial bottles as part of total drinks. Then we track how many empty bottles we currently have. While the number of empty bottles is greater than or equal to the exchange rate, we perform an exchange. Each exchange gives us new bottles to drink, which increases the total and also produces new empties to continue the cycle. The loop ends naturally when we don't have enough empties for another exchange. At this point, we have our final answer. Let's walk through the first example step by step. Start with 9 bottles, drink them, total equals 9, empties equal 9. Now exchange 9 empties for 3 new bottles, drink them, total equals 12, empties equal 3. Exchange those 3 empties for 1 more bottles, drink it, total equals 13, empties equal 1. At this point we cannot exchange anymore. The maximum is 13 bottles. Now let's try run the second example. Start with 15 bottles, drink them, total equals 15, empties equal 15. Exchange 12 empties for 3 new bottles, drink them, total equals 18, empties equal 6. Exchange 4 empties for 1 more bottle, drink it, total equals 19, empties equal 2. We stop here because 2 empties are not enough for an exchange. The maximum is 19 bottles. Here is the C++ solution. We define total as the number of bottles and we also track the number of empties. While the number of empties is greater than or equal to exchange rate, we compute how many new bottles we can get, add them to the total and update the empty count. Finally, when no further exchanges are possible, we return the total. The code is short, simple, and matches the logic we discussed. Now let's analyze efficiency. Each iteration of our loop reduces the number of empty bottles, so the process converges quickly. The time complexity is logarithmic relative to the initial number of bottles. In practical, if we're given the small input size, it runs in just a few steps. The space complexity is constant because we are only storing a few integers regardless of the input size. Why do we use simulation instead of deriving a direct formula? Because the constraints are small and the process is naturally iterative. Simulation directly mirrors the real world action of drinking, counting empties, and exchanging. It makes the solution more intuitive, easier to explain, and less error prone. For problems like this, simulation is often the clearest path. Although simulation is easy, we can also think of it in terms of general formula. At each step, the number of new bottles is equal to the number of empties divided by the exchange rate. The new count of empties is the remainder plus the new bottles just consumed. This formula repeats until exchanges can no longer be made. It's another way of understanding the cycle mathematically. What we can learn from this problem? First, that simulation is a powerful tool in problem solving. Second, that greedy strategies, always taking the best immediate option, can sometimes guarantee the optimal solution. And third, it reinforces how important loops are, especially in problems where a condition changes over time until it eventually fails. This problem is simple, but its lesson is broadly applicable. From 9 to 13, from 15 to 19, every empty bottle finds its worth. In the endless cycle of thirst, a puzzle so simple yet rich in exchange shows us the beauty of logic and the power of exchange. Thank you for your attention.